Hello everyone, will be some repair video for my portable network analyzer. I broke it around a few months ago, and for now I'll have to fix it and try it what's happening. I'm already know what the problem is, but I don't know how to fix it. So I just decided to record that video, and I'm very sorry for my English. If you're comfortable with it, you can stay here. So anyway, I'll try to show you some interesting things and my thoughts about it. Okay, let's try to power it up. Of course, it's looks like all is okay. Right now, my measurement device connected by coaxial cable on port 2. This is an output for port 2 of network analyzer, and this is an output for port 1 of network analyzer. So okay, of course I can't do it in case of that guy, but anyway, it's just a setup for show you where is the problem. Okay, looks carefully for some settings. Output power set by 0 dBm, carrier frequency set by 1 GHz, and we can enable the output. So let me show you scope screen. I'm really sorry about my scope because of I haven't proper spectrum analyzer right now for some reason, but it should be enough for our testing. Let me show you some channel configuration. Of course, it's coupling by 50 ohm resistor, input probe attenuation, of course, is 1 because of we just connected 15 ohm output to 15 ohm input oscilloscope channel by just a piece of coax cable. Okay, it should be fine, but if you look, probably you didn't see it, but for now, scope set it by 2 millivolts per division. It's very small amplitude. As we know, by 15 ohm resistor, you should see at least 600 millivolts at 0 dBm. So output level is enormously low. It's ridiculously low. And the same situation by port 2. I can show you this, but I have to repower the whole unit, so okay, it's not so important for now. We have to figure it out. We have to understand what's happening in PCB, in some block schematics. So let me show you block scheme, and we can try to find some components in PCB, probing it, and try to find broken component. There is a block schematic for that instrument. So we know our main problem. RF output power much lower than you set it by front panel, and it's lower on both port 1 and port 2. So some part from frequency generation should be broken, and we don't know where is exactly, how it looks like, and how it's exactly working, because of this block diagram is very poor, and as my point of view, it could be contain some mistakes because of PLO synthesizer market upper frequency is 3 GHz, but exactly this particular instrument could be working up 6 GHz. Probably some frequency doubling can be there, or up conversion stuff, but we can't see it right now, and I just can't talking about. Also one main thing, what I should say before, I'm not a professional at microwave engineering. I just want to show you my thoughts about that instrument and probably fix it and show you how I fix that. It's not more. I really can't teach you about how it works, what stuff happening here, so it's only up to you. I'm just showing repairing process. Okay, for now we can try to look at instrument more closely, probably probing something, connect our test equipment, measure some stuff, and other cool things. So go to the instrument. This is a test setup for our measurement. At first, I have to show you high frequency probe. This is high impedance, high frequency 3 GHz HP probe. So I will try to probing different circuits over there and looks an oscilloscope what's happening. Unfortunately, as I told you before, I haven't proper spectrum analyzer, so we can use just Electrical oscilloscope, which is unlocked to 3 GHz, and it should be enough for our purposes. Instrument already boot, and we can enable output. This is an output from port 2, which is connected to sorry, it's very bad setup, but okay, it should be enough. This is an output from port 2, and blue line, it is an input from my high frequency probe. So right now I'll try to probe some RF component over there. So if you look at set working frequency, it is 1.5 GHz, and we know 1.5 GHz it's upper band for that instrument. So we have to probe at first frequency generation part. I'm very sorry for shaking my camera, but I haven't any other way, and again sorry for this. I'll try to make it much more comfortable for you. Probably there is no way to do that, so okay, let me adjust a bit my waveform. So this is an input from my high frequency probe. Right now I'll try to connect this directly to RF switch input. This is actually one of the differential output from this synthesizer. And yeah, we definitely can see something. Yep. So From this synthesizer we can see much more higher amplitude, even directly from port 2, but we know there is some amplification, so even at input of the RF switch we can see, sorry, I really have to adjust it again. We can see around 200 millivolt peak to peak amplitude. Yeah, roughly so. But at the port 2 we can see just 10 millivolt. It's ridiculously low. So okay, let me find next component. This is an output from switch and input to attenuator. And again, it's looks very reasonable amplitude. 200 millivolt, it's very much. Okay, goes to peregrine attenuator. From output of attenuator we can see some, but it looks like it's very low amplitude. So let me measure output from amplification stage. Yeah, that's very nice. It looks very reasonable. It's around 200 millivolts per division, 200 millivolts peak to peak, 100 millivolt per division. Okay, we can try to measure next point. It's after mystery component. I actually haven't idea of what it is, so let me probe it. It looks like there isn't broken stage, because of at the input of that component we can see 400 millivolt per to peak to peak amplitude, but at the end of that component we can see just around nothing. It is really hard to see because of noise level is very close to my measurement level. I can try to measure it without attenuator, but it's a little bit worrying me. Okay, anyway, I'll try to do it. Sorry for some correction on scope. Okay, at the end of the probably broken component we can see very strange situation. Okay, let me adjust a bit. I do it first time. Okay, very strange situation, and we can see around 30 millivolts peak to peak. It's very low, so we have to find what component it is. We should check datasheet and try to find some replacement for that. Here is our PCB. Let me show you again what I did before. I measured some points over there at frequency generation block. I started from main frequency synthesizer, which works up to 6 GHz. I've measured probably positive output from differential pair, which is goes to actually negative part of differential pair goes to terminator, and positive goes to high frequency switch. Other input from high frequency switch goes to low frequency generator, and I've measured this point exactly at the input of the high frequency switch. At the output of the frequency switch, I've also seen reasonable amplitude, and this is peregrine step attenuator. It also seems like working. We saw quite low amplitude over there, but we seen very nice and power amplitude at the end of the first amplification stage. So I've measured exactly this point. At this point we saw 400 millivolts peak to peak. So this is an input to RF gain block, which is marked like 788A. I'm very sorry for quality of photo, but I haven't proper photo equipment right now, so it should be now, just trust me. Okay, let's go to the next point, which I measured exactly this point. So at this point we saw 400 millivolts, and at this point we saw just tenths of millivolts. So this is IC. It is analog devices HMC 688A. It's actually Hittite, if I'm not mistaken. So it works up to 10 GHz. It's quite a lot. But at the end of the input we can see around nothing. So there could be two different situations. At first, output could be short. It could be short by this switch, so I have to desolder some components over there, test it again, and after this we can make some conclusions. Work this component or not. So if this component not working, I have to buy that IC, replace it, and measure it again. So let's do some measurement again. Check output power without any load from this circuit. I have to add some termination between ground and this point and measure it again by high frequency probe. I've made all requirement changes in PCB. I've disconnected all things from RF gain block, which is actually one of the mixture for down conversion, and switch for some ports connection. Okay, now we can try to measure what's happening at the input of the RF gain block, and after that we can try to measure output of RF gain block. Okay, power on our output and probing input. Oh, sorry, it's much overload. Yeah. This is an input from RF game block. It's really hard to measure. Of course I haven't proper ground connection, and this is a reason why signal is so small. Right now it's around 200 volts peak to peak. So we can go at the output of RF gain block, and we should expect it more power than at the input. So I've connected to output of RF gain block, and there is sorry, I lost the focus, and there is around nothing. Let me adjust the scale a bit. Roughly 20 millivolts peak to peak. It's very low value. So yeah, we definitely have to replace that RF gain block and see what's happening next. After a week I bought a couple new ICs, so there are, and there is a broken AC which I already desoldered, sorry, and already installed new ICs from this package. So let me show you current situation. That's the scope input. You have to connect this directly to output of VNA. Right now VNA is stopped, so we must see nothing, and there is exactly nothing. Right now 0 dBm as the output of VNA, so we can turn it on and look at nice sinusoidal signal. Roughly 500 millivolts. It's lower than 0 dBm because of we have bandwidth of the scope itself. We have cable over there, some BNC SMA connection, and and VNA don't have to output exactly level what you set it by the instrument, because of VNA actually doesn't so much care of output power, because of you have to measure some power relation between two ports or on one port. For testing actual output power, I've bought much more interesting things. This is where is my focus? Yeah, there is Anritsu power sensor. Okay, of course is just overkill setup for our measurement, but it should be enough. This is, sorry for shaking, guys. This is display of that sensor. So I have to turn it off. Yeah, well, and change some cables. It's not right do it on the power, but I have no choice for now. Okay, you can turn it on and see 0 - 0.4 dBm. It's very nice. Yeah, it's quite good. 1.5 gigahertz. We have to setting this power actually. Okay, it's maybe there. No. Okay. Yeah, I found this. Yeah. Sorry guys, I didn't prepare for doing that. Yeah, it looks quite the same. Try to change the frequency for high value. So for example 5 gigahertz. 2 dBm looks quite nice. Try to change the frequency again. 5 gigahertz. Yeah, probably changing nothing. Okay, yeah. It looks fully repaired. So for now I have to show you the reason why this instrument failed and how it happens, how you can avoid this actually. Let me close it, bring it back to case, and we have to measure something much more interesting than RF stuff. And there is a reason why network analyzer was broken. It's just a regular charger for this network analyzer. I can plug it in line, plug it in VNA, and yeah, we can see charging. I can power it up. Yeah, very nice, boot quickly, looks good, and I can measure output voltage from power supply. It should be 12 volts. Yeah, 12 volts, quite stable, looks good. But the most interesting measurement what I want to show you, it's just AC measurements. I want to measure AC voltage between ground of the instrument, which is connected to charger, and some earth connection between lab. So one of my probe goes to this ground and one of my probe goes to this ground. 71 volts AC. It's very a lot. It's quite a lot. Another connection. 71, 72 volts. And another connection. 64 volts. It's so a lot. I didn't understand why you sell your high price device with that crappy power supply. It is let me show you, Asian Power Devices Inc. with safety marks. You look at safety marks. It's so safety for the instrument. You just can easily avoid this only by adding some earth connection over there. You really have to add your earth connection at the switching mode power supply. It's not a transformer power supply, of course, because of its transformer is very old technique, and you can see it only in linear power devices, like some power supply like this guy. It's very abnormal. You really have to avoid AC voltage from the input to the output, and you can easily make it with some earth connection. Earth connection leakage, AC connection, AC voltage leakage from the input to the output is very understandable, because if you have some capacitors between high voltage side and lower voltage side, just for keeping AC loop for noise is closed. It's all doing only for some certification purposes, but of course you can pass some certifications, got a safety marks, but it's fully unsafe for your instruments. So yeah, we actually can't use that anymore, because of if you're working with that charger, you should be very careful. So I hope you enjoy the simple repair. It's something complicated. For future, I'll try to make it much more interesting. Probably I show you some interesting experiments, some schematics or other electronic stuff I actually don't know. So look forward to that, and thanks for watching.